All right, so we left off on Monday anyway, on chapter 1, and you guys let me know if I'm ever going too fast, because I try to just cover everything as we go. So if any point you're like, hey, I'm not getting what I need out of it, just let me know. I'll slow down. Feel free to stop and ask questions at any point too. So we'll go ahead and finish up with chapter 2. We don't have or chapter 1, sorry. Part 2 of chapter 1. Was everybody able to see the Canvas stuff that's up?
Yeah.
See the module? I saw a lot of people put the introductions on there. We're working with the way it's set up right now. You have the prerequisite, so you finish module 1 before you can move to module 2. Not exactly sure how that's working on your all's end. Just let me know if there's any difficulties with that. So for module 1, it was the one thing that you were supposed to do is just go on the discussion forum and introduce yourself. And then once you did that, it should open up module 2. Everything should be up there now, including the quiz for chapter 1. And also our first lab, which I'll explain here in just a little bit.
The one thing I'll say, just as a reminder, he's got 3 things in the first. It's like the introduction link, and then it seemed like there's a link to the syllabus. You might actually have to click that to trigger it as well. Even if you already read the syllabus or I printed out the syllabus, if module 1 doesn't show up, make sure you actually click every link in that first module.
Okay, that's part of the prereq as well.
Had that problem.
Okay. Yeah, so to click every link, that'll allow you to progress too. And you should be able to kind of go in and view it like as a page, and at the bottom there will be an arrow to go to the next thing, and that should check that box saying that it's finished too. So, all right. So we were talking about genetic engineering and genetic modification when we left off last time. And I just kind of wanted to reiterate there on the genetic engineering front, just a little bit about that. So again, I think that genetic engineering is a much better term than genetic modification. One, because we've been genetically modifying crops, pretty much forever. Plant breeding is genetic modification in a sense. So calling something a GMO, I feel like this is not an accurate term. So genetic engineering, however, is what we're doing in the lab, right? They're actually taking genes, in some cases, from entirely different organisms and inserting them into the crop in question. The vast majority of crops that have been released to the public and been FDA approved are basically the subsidized commodity crops. None of the vegetable crops that have been genetically engineered are actually available to the public. And you hear these different rumors about some of them. Like one was called the Flavor Savor tomato, and they released this in the 90s. They actually did a trial where supposedly it made it to the grocery stores. And I don't know if this is true, but the rumor was that they took genes from a salmon and inserted it into the tomato genome. The idea was to make the tomatoes keep longer, so they had better shelf life. And that, kind of the way that we do tomatoes on a large scale is we'll harvest them when they're still green or maybe just starting to get a little bit of color. We'll ship them across the country or across the world. And in doing so, in the shipping process, they're often gassing them with ethylene, which is also a natural plant hormone, which causes the tomato to continue to ripen. So by the time it gets to the store, it's red, and it might be hard as a rock, but ideally it tastes a little bit better because it's more ripe. The sugars have continued to respire and develop. Anyway, that's how like the tomato system is currently. And if you have ripe tomatoes that taste really good, they have poor shelf life. So that's the whole reason why they harvest them green. So the idea with this flavor saver tomato is we can harvest them ripe, but they'll still be, able to last on the market. However, apparently when they put them out, they tasted horrible. They tasted like cardboard, is what a lot of the consumers said. So they didn't end up continuing with that. They withdrew it because nobody would buy them. So it kind of one of the unintended consequences of genetic engineering is that it might taste bad, right? So anyway, that was withdrawn. The genetically engineered crops that are out there, and you might have read this in the chapter in the book.
Did you interrupt, or were you trying to share your slides? Because we're not seeing them.
Oh, not yet. Yeah, I'm sorry, I haven't gotten there yet.
I thought you were doing an intro and not, but then I heard your mouse click. I just want to make sure. Okay.
It's the genetic engineering. The Roundup Ready, we mentioned this on Monday, but the Roundup Ready crops where basically you can control weeds just by spraying Roundup on the whole field. So we have corn, soy, wheat, now sugar beets too. These are all Roundup Ready crops. Or those that are BT ready crops that are actually producing the Bacillus thuringiensis in the plant itself. So insect larva comes along, feeds on it, it dies because it ingests that BT itself. Those are like the two main ones out there right now. We also mentioned the vitamin A, the rice that's been incorporated with beta carotene, so it produces more vitamin A, which prevents blindness in kids in Africa. They're good merits, I feel like, but those are really the only genetically engineered crops that are out there, and they're all for the commodified and subsidized crops. So we see a lot of products that are labeled GMO free when really they wouldn't have a genetically engineered crop in them anyway. So just wanted to continue that conversation a little bit. Let me go ahead and share my screen with you guys, and we'll get back to the second part. Is that coming up for you guys?
Yep.
Yes.
All right, good deal. So part 2 of our chapter 1 talk, and I'll apologize because usually what I'll try to do is put these slides, the slide sheet anyway, up before class. So for chapter 2, I'll have that up to where you can go ahead and go on there, download the note page, print it off, and then you can take notes along with it if you wish. So we'll make sure to do that for chapter 2. We don't have a whole lot here to finish on chapter 1, but we'll go ahead and kind of talking about the sustainability aspect here in meeting the challenges in plant science. So this model for the ecological paradigm in agriculture was actually developed at Ohio State University. And OSU is one of those land grant universities. Every state has one, at least one, where basically the federal government set aside some land so that they could develop some sort of agriculture programming. And so OSU, Ohio State University, is the land grant university for Ohio. Lots of things that they do, but they engage in some agricultural research. And so one of the things that they were looking at here was kind of the ideal of sustainability in agriculture. And it looks like my highlight kind of disappeared or went up to the top. But nonetheless, they're looking at these 4 areas of focus for sustainable agriculture. And one is just the efficiency of production. So how do you efficiently produce the crop itself? And what is the technology associated with that? Along with that, we look at kind of the 3 pillars of sustainability. So that's economic viability. You have to make money off of it, right? And I feel like that's a big one probably the most important initially, because if we're not making money off of the product, then it can't be sustainable. We can't continue to sustain it. So lots of things that go in with the economic viability piece that are connected to that production efficiency. How can we use fuel efficiently to the point to where it is cost effective? For instance, using a tractor to plow your field. At what point is that cost of plowing the field justified? By what type of plow, et cetera. So the economic viability is strongly linked there with the production efficiency. The next thing we look at is environmental compatibility, if I can say that correctly. Does it make sense to produce the crop? So we have a greenhouse here at maybe one day we'll actually take a little tour through the greenhouse and post a video just so you can see what we're dealing with here. We like to grow tropical crops in it. And we actually had some donors to our program to help out with the building of the greenhouse. And they were really interested in growing bananas. So we did. I mean, we grew some bananas in the greenhouse. We were able to get them to fruit in the greenhouse, harvest them. And they're these small bananas. They're delicious. They taste really good. And they were like, well, we should be promoting growing greenhouse bananas. But really, does that make sense? I mean, even in this modified environment, does it actually make sense to grow bananas? With all that embedded energy, that emergy, the production efficiency is not cost effective. We have to spend way too much money in heating the greenhouse to keep it above 40 degrees in the winter to keep the bananas alive to where they will produce. So is that compatible with the environment? Another way we could kind of look at that is maybe trying to grow bananas outdoors. You guys seen that before? People will actually grow bananas like as an ornamental plant outdoors. We see it here in Southwest Virginia fairly frequently. And actually, every once in a while, they might even fruit, which is kind of bizarre, but they're hardy enough to where they'll die back to the ground. They'll resprout each year. It's kind of a cool looking ornamental plant, but we don't have a long enough season most years for them to actually fruit. So it's not compatible with the environment. We can also look at the ecological costs associated with the environmental compatibility. The runoff of fertilizers, for instance. So in our system of industrial and kind of globalized economy, our agriculture is based on, where can we most efficiently produce the crops. So we're looking at like tomatoes, for instance. Most of them are grown in either Florida, California, or Mexico that are consumed in the United States. And then they're shipped, around the country, in some cases around the world. Because that happens to be the most compatible environment to have the greatest production efficiency. However, there are some hidden costs there. The carbon footprint of transporting the tomatoes, for instance, shipping them, thousands of miles, when basically, a tomato is like 90% water. So you're shipping this little packet of water. Does that make sense? What are the hidden costs? Which also leads to the social responsibility aspect. And the social responsibility, I think, is probably the most difficult part of the sustainability paradigm to kind of grasp. We think of it as paying the workers a living wage, for instance. That's really difficult to do on the farm. You guys probably know, if you've been involved in any agriculture production, cost accounting, like for your time, can be kind of depressing. We actually looked at doing that for just one crop, for instance, kind of doing a sustainability study on our farm when we were growing tomatoes in a hoop house. And we basically figured out that with all the time that we invested into it, that we would probably be paying ourselves what we're making in the end, paying ourselves somewhere about $1.25 per hour. Is that socially responsible? Since we were the owners of the business, it was okay, right? And we were all right with that way of life. But can you get away with paying someone $1.25 for agricultural labor? Probably not. That goes to say something maybe about our production efficiency there, and maybe it also goes to say why I'm no longer growing hoop house tomatoes. But nonetheless, that social responsibility aspect is there. If we look at tomatoes being grown in Mexico and being shipped, some of that social responsibility could be compromised because, they're paying them a much lower wage to do it there because they can't. Or for instance, if we use illegal migrant labor in parts of the country, there's a big social issue there because since they're, perhaps an illegal immigrant, they are not documented. They're undocumented workers, and we're not paying them the minimum wage that we're paying the documented workers. We might also not, be paying them or giving them any type of benefits. Also, they're not paying taxes too. So there's all kinds of things in the social realm there that I think make it really difficult how do you do that properly? Anyway, so this is a huge challenge in plant science. What are the answers to make agriculture, more sustainable? If we disregard, one dimension of this pyramid of sustainability, then it compromises the whole structure, is kind of the idea at Ohio State University. So keep that in mind. How can you produce something and be socially, environmentally aware while making money and being efficient? Can technology be a part of that solution? Possibly. Could a mechanical picker be part of that? Maybe. I mean, these are all things to weigh, and looking at these kind of pillars of sustainability, I think, are extremely important when examining any kind of agricultural production. All right, let's move on and look at kind of establishing some of these solutions. So we're going to talk about the scientific method here. So what is the scientific method? This systematic approach of understanding and solving the problem. Let me hide that from you guys. I feel like this is taking up too much space. So the scientific method, we have these clear steps to trying to understand and solve a problem. And the first step is that we identify the problem or the question. There has to be a problem in order for us to solve it, right? So once we identify that problem or question, we create this hypothesis, this educated guess of what the cause of that problem or question is. And generally, we try to make the hypothesis, this educated guess, something that can be provable through experimentation. So the next step is to test that hypothesis by doing some sort of experimentation or study. In some cases, we might be able to just look through other people's research to answer that question. Maybe they've already done experimentation to establish whether that problem or question is solvable. And anyway, then we'll check and interpret the results. So throughout the experimentation, we are gathering data. And that data can take many different forms. But we have to analyze and then interpret that data. And finally, we report those results, often in the form of some sort of scientific paper. Could be published or it may not be published. So when we're talking about the hypothesis, we think of taking the idea and stating it such as this is the source of the problem, or this is how this process could be improved. And then after our research and experimentation, we develop this description of how the data in our experiments prove or disprove our hypothesis, and ways that we can correct the problem. So we do this in controlled experiments, because really that's the only way that we can obtain reliable information. And it's difficult to do these controlled experiments. A lot of times we might do this in a controlled environment so that we're trying to limit the variables that could affect the study. So for instance, in plant science, we do a lot of these experiments in a greenhouse. So a lot of times we do this in kind of an artificial situation. So we're examining just a few variables. And we look at these variables such as the independent and dependent variables. So when we're looking at, in this example of an experiment, we're looking at growing plants having all the uniform characteristics, but growing them in a compacted soil. So all the other same characteristics are the same, because we're growing them, say, in a greenhouse, and we're growing this type of plant. The type of soil is called the independent variable. The plant growth is what is changing, the value that is changing based on that type of soil. So that's the dependent variable. The compacted soil is a different treatment. The uncompacted soil, where it's naturally growing, would be our control. So our control we use as the check. And generally, you're just growing it under unmodified conditions so that you have something to compare it with. You always have to have that control to be able to validate your data and your experimentation. The other thing that we have to do in order to validate our experimentation is to replicate the experimentation. We don't just do it, say, just comparing one control. They were growing it in a container. We're growing like beans in a potted container in the greenhouse. And we don't just have one that we have uncompacted soil versus one that we have compacted soil. We try to replicate that experiment as many times as possible. So in this case, we have both replication and randomization in this experiment. So they're randomly arranged in different places. So that might take some of the environmental considerations, those variables out of it that could, the extraneous variables that could change the experiment. Like a, say, like a cool spot or a hot spot or a shady spot. We would want to irrigate these containers the same as well, making sure they all get the same amount of water. These are arranged randomly in these containers so that we get that randomized replication, so that there is any bias that we have is removed. And that randomization would take into account that no two plants are exactly alike, even if we've cloned them. You know, we've taken, which is something you would want to do. You would want to basically make sure that the genetics are all the same of these beans too. So rather than growing them from seed, we would want to asexually propagate them. However, even with that, there can be some subtle differences, such as from mutations or those slight environmental differences. So we randomize them to account for that. We might mix the size of the plants and the treatments in order to get that randomization and replication too. The replication, we would do multiple containers, maybe multiple plots, maybe have them in multiple rooms too. All other variables, though, we try to keep the same to be able to get reliable data that we can also statistically analyze. Speaking of statistical analysis, that's our favorite part, right? Everybody loves statistics, or what I prefer to call sadistics. Sorry, nobody laughed at that. I thought it was a pretty good joke. Anyway, basically we look at the statistical analysis as a way to check the data, to really truly see whether the hypothesis is true or not. So we would create this null hypothesis, and we would look at it basically as not just physically examining it and saying, all right, well, the plants that were in uncompacted soil grew better. No, we actually have to plot out the heights, the different sizes of the plants, in order, and then actually run it through some sort of statistical analysis system to prove or disprove our hypothesis. And in many cases, this scientific experimentation, I mean, it's extremely important, but I feel like it can also be somewhat skewed, depending on how you analyze it statistically. The best way, I think, to do it, and if you guys decide to go to graduate school, you'll probably have to do some statistic analysis at some point. But ideally, a lot of researchers, they won't do the statistical analysis themselves. They will send it to a statistician, whose job it is to basically analyze these statistics on a regular basis. So they're used to doing it. And they're more likely to, do it correctly and remove any potential bias, because you can, in some cases, manipulate the statistical method of analysis in order to get the results that you want. So keep that in mind when we get to the point to where we're starting to do some research. Look at who's doing the statistical analysis. Look at multiple studies. That's the other thing about replication. The experiments have to be replicatable. And that's why we are reporting the results of any scientific study or experimentation we do, so that someone can replicate that experiment and continue to disprove or prove our hypothesis. All right, so last thing here on data interpretation, really kind of just what I just said there. Allowing it to be, reporting it in such a way that it can easily be replicated so that future researchers can compare their results and methods to yours. They might actually potentially change a hypothesis, but still use the same methods and might get totally different results. There are just so many different extraneous factors that are so difficult to account for that even in a highly controlled environment, it's just, you can't account for every little thing. So, all right, I think that covers chapter 1 there. Go ahead and ask you guys, y'all have any questions, comments, concerns about chapter 1?
I've got a general question with ethanol being 10% ethanol in gasoline. Has the corn crop been modified to boost? Is it different from other uses for the corn?
Oh, that's an excellent question. And
the only reason I bring that up, that's well in contention now with the refiners of food products. But I'm just wondering, do they use the same corn? Let's say the corn that's grown in this state, could it be used for ethanol production, or it's got to be specific corn?
That's a great question, Jeff. And I can only answer that through my experience, because I haven't done a whole lot of studying on this since my experience. I have visited a few different ethanol plants, and we don't have any nearby here. So these were, when I was living out west, we visited a few in Arizona, in the Southwest, and they were always accompanied with a feedlot. So they actually had all that corn being produced. Anything, they actually still fed the corn itself, the grain parts, to the animals, but they took the leftover product and used it to turn into ethanol. So in those cases, and I don't think that's always the case, and I do believe that there has been a lot of research. I don't know of any that have been actually released, but there has been a lot of research on doing some genetic engineering to increase the biofuel capacity from like corn and sorghum, et cetera. But all of the ones that I've seen were accompanied with a feedlot. So they were feeding a part of it to the animal and then using the rest to actually create the ethanol.
Okay.
Fascinating thing though. And, I think this is, they're working on this right now, but unless it is, paired with a feedlot, it really doesn't make sense to do it, at least at the time that we were visiting these. And this was back in 2010. So, in the 9 or 10 years that this has changed, it's possible that it has changed. That's all I'm saying. Hey, do I get a sun drop too?
If I figure out how to attach one to an email, I'll send it to you. Yeah, Jeff decided he hasn't ever had one before, so.
Nice.
I actually converted one of the math teachers, got her on board a week ago, so.
Yeah, it's 7 up.
Okay, so
Interesting.
I think one of the big criticisms though of like the biofuel stuff is basically that we're taking food away, something that could be consumed. However, in those cases, the ones that I saw, we're not. We're still feeding it to the animals. So it was funny because you see this ethanol plant in the middle of this huge cornfield that has a feedlot on the edge. So they're kind of doing it all right there. And of course, there's a railroad tracks coming right to it. So they're also getting in shipments of, corn to turn into ethanol as well. But usually they're not using the grain aspect. They're feeding that to the animals and then using the rest of the plant. So that's the short answer. I hope that at least is part of the paradigm. All right. I want to go ahead and kind of show to you guys the rest of the or just an example of the lab here that I'm going to ask you guys to do. And I'm going to have to do some figuring on this, and I might need your help on this, Tom, but we're going to look at how we can do this lab. I have it right now set as an assignment, so I think you might have to complete it in order to go on to the next module. I might just have to remove that, though, so that you can advance without, because the due date is not for another couple of weeks for this.
You can adjust that to not make it a portion to have to complete it.
Maybe just remove the prerequisite or something.
Yeah, that's pretty much what I do.
Okay. So I'll share this with you. You guys probably haven't seen this because I just put up the lab this morning. We changed it a little bit from last year. So you'll go to your college login. You'll log in. You'll go to Canvas. And, of course, this will look a little bit different to you since I'm in the instructor view. Actually, I guess I could go to student view just to see what it looks like. So we'll go to our modules here. And week 2. So you should see all this. You'll have lab 1 is where our food comes from. All right, so this is a take-home lab, and basically what I want you all to do is try to get a better understanding of where our food actually comes from. Because in this, kind of globalized economy with this industrialized agriculture system, these food products could come from all over the world. So I just want you guys to go to 3 different purveyors of food products. Go to at least one large grocery store, ideally a chain. Like here we have Kroger's. That's our big, kind of national or multinational chain that we have here. What do you guys have there?
Wally World. Food Line.
Food Line, Walmart. Those are great examples of the large chains. Also, try to go either to a local grocery store or a farmer's market. I would prefer a farmer's market, but farmers markets are often open for limited hours, so you might not be able to make it to one. Try to go to a local grocery store. One of the ones that we have here is like Food City or Food Country. Those are 2 of our kind of local chains. They're still chains, and Food City is a little bit larger. But the point here is somewhere that offers some local products. Our Food City, although it's becoming kind of a larger chain, and probably one day it will be a national chain, they have kind of in their bylaws, or however they operate anyway, that they dictate that they have to buy a certain amount of products from the region. So the point here is just to get to some sort of local provider of foods. Ideally a farmer's market, that way you can talk directly, in many cases, speak directly to the person producing it. I think that's one of the better ways to learn about it, and could create many more conversations too. But a local grocery store would be fine too. Then finally, go to a restaurant of any type. That could be a fast food restaurant, could be a sit-down restaurant, any kind of restaurant. Somewhere that takes products to make, some sort of value-added meal, whether it's a value meal or not, right? So that's the first step. Find these 3 different purveyors of food products, go to them, and create a list of at least 20 different food products. And of those 20 different products, at least 5 of those should be a processed food, and at least 5 of them should be a raw product. After that 5, the mix can be whatever. Also, feel free to get the mix from those 3 different food purveyors, however you would like to. Then for each food product, you got the list of 20. You want to answer as many of the following questions as possible. At the minimum, answer what is the type of product, and include like a title or a product name if it has one, a brand name if there is one, where it was examined. So, what was the food purveyor that you were looking at? What is the cost per unit? What is that unit? What is the main ingredient if it is processed? For instance, if you're going to a restaurant, what is the main ingredient? Say you're getting a Big Mac, for instance. What's the bulk of that? Is it the 2 all beef patties? What is that product? Where does it come from? So that's the next question. Where did that main ingredient come from? And try to be as specific as possible. Include the country of origin, if you can, the state or province, or maybe even the farm, if that is possible. And if that is not readily evident, then speak to someone at the store, like the produce manager, or do some further research. Google the product, if it's a processed product, to see if you can find out where it came from. And then finally, are there any special labels for the product? And in the marketing world, we kind of think of these as like the premium pricing opportunities. Like, is it organic, or is it GMO free, they might say, or certified natural? So at the minimum, I want you to at least answer the first 3 questions using the product type, the location, the cost per unit of each item, and then try to make some comparisons. So if you do, say you're going to look at tomatoes, for instance. You look at a tomato at Kroger's, a vine ripened tomato that was greenhouse grown, we'll say. Write that type of product. Maybe it has a title such as, let's just say, the Campari Fresh, greenhouse grown, vine ripened tomato. Include that if it's got that, as part of the product. And then say I looked at this at Kroger's. And then what was the cost per unit? For 6 tomatoes or 1 pound of tomatoes, whatever, it was $3. In this case, what is the main ingredient? Hey, it's a tomato, right? Where did it come from? So in some cases, if it's packaged, it'll say it right there. If it's not packaged, a lot of times it'll have a sticker on it. That sticker, might not say where it's from, but the produce manager could tell you where it came from. So try to talk to a produce manager, especially at a grocery store, or if it's farmer's market. Our farmer's market's interesting in that they don't allow people to sell products that they didn't grow. A lot of farmers markets do, though. So, ask the person at the market stand whether, they grew it or, if they didn't, where did it come from? And then in this case, we're trying to compare them. So let's say that we're looking at tomatoes. One would be a tomato from Kroger's or Albertsons or whatever, a food line. 2 would be a tomato from the farmer's market. And then we'll compare, the cost of them. So, but those would count as 2 different products since you're looking at 2 different places. Does that make sense to everybody? I'll try to post an example too. Do you have a question, Jeff?
Yeah, one of the problems is the people you ask may not know the cost of the product.
Oh, yeah, that's a good point.
Particularly in Wally World, because
yeah, in that case, like if it's a processed product, just look at the product itself, like the whole package, rather than just the main ingredient. So let's just say if it's like I don't know, a box of pasta, for instance. Say how much is the box of pasta rather than how much did the wheat cost to make the pasta. Does that kind of answer your question?
Yeah, but even going to the farmer's market, typical individual probably doesn't really know the true cost of the product.
Right.
That they produce, because they're not counting their time or anything.
Oh yeah, that's an excellent point. So I guess in that case, try to look at the cost of the product to the final, end consumer, rather than the cost to produce the product. If you can find out that information, though, how much did it cost to produce it, that would be awesome to see. So we'll have some follow-up questions for this too, but I guess at the minimum, try to answer those 3 questions as good as possible, as completely as possible. It'll get you moving around quite a bit, but it's a fun assignment, and we'll kind of break down. We'll also put up a little discussion board just to discuss what you guys, kind of learn from it and what those cost comparisons are. So, for instance, our farmers market, we actually regularly are the board, the steering committee there will go into the grocery stores and compare the cost of, what they're selling at the farmers market to the cost of what it is at the, Kroger, for instance. And, a lot of people will say, oh, I can't shop at the farmers market, it's too expensive. But they're saying, well, in most cases, we're the same price or maybe even cheaper. So can we answer some of those questions and, prove or disprove that? That's kind of what I'm looking at there. Any questions on that? So the due date is September 8th by 11:59 p.m. So that's not this Sunday, but the following Sunday at midnight, or by midnight, I should say. So as long as you get that turned in whatever format you want to, that could be a, Word document, to spreadsheet, a PDF, upload that. Or you can also just submit it directly into this submit assignment prompt. It'll give you a text box itself. But just do that by September 8th. That way, on that following Monday, we can have a little bit of discussion on that. Anybody have any questions, comments, or concerns there? Good deal. Well, I'll fix that to where you guys can progress to Module 2 once you've completed the quiz. And that will be ready for us next week. So next week, of course, we don't have class on Monday due to the Labor Day holiday. So you all get out and enjoy your Labor Day. And maybe go do your lab, right?
Okay, well, try to Labor then. Okay.
Yeah.